The Fantastic Four get their powers from cosmic ray exposure during a space mission. Reed Richards becomes infinitely elastic. Sue Storm turns invisible and generates force fields. Johnny Storm bursts into flame at will. Ben Grimm transforms into a rock creature with superhuman strength. This origin story has existed since 1961. Stan Lee and Jack Kirby needed something that sounded scientific. Radiation was mysterious and powerful in the public imagination, perfect for granting superpowers. 63 years later, we know exactly what cosmic rays do to human bodies. The answer isn't superpowers, it's cancer. Cosmic rays aren't rays at all. They're high-energy particles, mostly protons, some alpha particles, heavier atomic nuclei, traveling through space at nearly the speed of light. They originate from the most violent events in the universe: supernovae, active galactic nuclei, possibly black hole accretion disks. Some cosmic rays carry energies millions of times higher than anything we produce in particle accelerators. When these particles hit matter, they create cascades of secondary particles. One cosmic ray striking upper atmosphere produces showers of thousands of secondary particles that reach ground level. On Earth's surface, we're protected. The atmosphere absorbs most cosmic radiation. Earth's magnetic field deflects charged particles. At sea level, you receive about 0.4 millisieverts of cosmic ray exposure annually. Negligible. In space, there's no protection. Astronauts on the ISS receive 200 millisieverts per year, up to 500 times the ground-level dose. Beyond Earth's magnetic field, exposure increases further. Apollo astronauts reported seeing flashes of light with their eyes closed, cosmic rays striking their retinas directly, causing momentary visual sensations. That's not a superpower. That's radiation hitting your eyeballs.
We jump to the present day with the Fantastic Four facing off against a villain known as the Wizard. Now in truth, this battle is not really designed to play any major or significant part. Instead, this is simply designed to show us what the Fantastic Four are doing in the current day, and that this era of their life.
If this changes how you think about space radiation, drop a comment. I'll cover more about real space hazards in future videos. High-energy particles passing through tissue cause damage at the molecular level. Each particle breaks chemical bonds as it travels. DNA is particularly vulnerable. Single-strand breaks usually repair successfully. Your cells have mechanisms for this. Double-strand breaks are more dangerous. If both strands of the DNA helix break near each other, repair mechanisms can fail or introduce errors. Accumulated DNA damage leads to mutations. Mutations in the wrong genes lead to uncontrolled cell division. Uncontrolled cell division is cancer. Acute radiation syndrome, what happens with sudden high-dose exposure, proceeds through predictable stages: nausea and vomiting within hours, a latent period where you feel better, then bone marrow failure, immune collapse, gastrointestinal damage, organ failure, death. The Fantastic Four would experience massive radiation doses in their depicted scenario. Their cells would die, their DNA would fragment. If they survived initial exposure, they'd face dramatically elevated cancer risk for life. What radiation doesn't do: rearrange your molecular structure into something new and stable. Grant abilities that violate physics. Turn you into a rock creature that somehow still thinks. Radiation is destructive, not creative. It breaks things. Reed Richards becomes infinitely elastic. He can extend any body part to extreme lengths and return to normal shape. Human tissue has defined mechanical properties. Skin can stretch about 150% before tearing. Muscle fibers have specific maximum elongation. Blood vessels rupture under excessive strain. Even if Richard's cells somehow became elastic, capable of extending without breaking, he'd face impossible physiological challenges. How does blood reach a hand 30 feet from his heart? The cardiovascular system can't pump through tubes of arbitrary length. Pressure drops with distance. His extremities would be bloodless, necrotic. How do nerves function across extended distances? Neural signals have propagation delays. A 30-foot arm would have noticeable lag between thought and movement. How does he maintain body temperature? Extended surface area means massive heat loss. He'd freeze or need enormous metabolic output to stay warm. The biology stops working immediately. Richards isn't elastic, he's impossible. Sue Storm bends light around her body, making herself invisible. If light bends around you, none enters your eyes. You can't see. Invisibility as depicted requires light to bypass the observer, but somehow still provide visual information. This is contradictory. Some proposed invisibility technologies use cameras on one side of an object, projecting to displays on the other side. Active camouflage that simulates transparency. This works for objects, not for beings that need to see through their own invisibility. Sue would be blind every time she turns invisible. The film either ignores this or invents additional physics to work around it. Johnny Storm generates fire that covers his body without consuming his flesh. Combustion requires fuel. Normal fire burns material. Chemical reactions that release energy while transforming matter. The fire consumes its fuel. Storm's flame appears continuously without him losing mass. He remains the same weight after extended flame generation. Where does the energy come from? What's actually burning? The hand-waved explanation involves some kind of plasma field, ionized gas surrounding his body. But maintaining plasma requires enormous continuous energy input. Where's the power source? How does his metabolism generate megawatts of output? Conservation of energy doesn't disappear for fictional characters. The fire has to come from somewhere. The Fantastic Four. First steps will hand-wave all of this. It has to. The powers are iconic. The film will probably show cosmic rays as glowing visual effects. The transformation will be dramatic but vague. Pain, flashing lights, change bodies. Science-sounding dialogue will provide cover without explaining anything. This is fine. Comic book movies aren't physics lectures. The audience wants to see Mr. Fantastic stretch, the Human Torch flame on, the Invisible Woman disappear. The origin story is justification, not explanation. But if you've ever wondered why Reed Richards doesn't hemorrhage every time he stretches, why Sue Storm isn't blind when invisible, why Johnny Storm doesn't burn himself, this is why the questions matter. The physics doesn't work. It's magic wearing technological costume. The Fantastic Four's cosmic ray origin made sense in 1961. Radiation was mysterious. The atomic age had demonstrated that radiation could transform matter. Mutation was real. The public understood that exposure could cause changes. What wasn't understood, radiation causes damage, not enhancement. Mutations are overwhelmingly harmful. The changes that radiation induces kill organisms rather than granting abilities. 60 years of continuity have cemented the cosmic ray origin as canon. Retcons would alienate fans. The films are stuck with a premise that was always more poetic than physical. Cosmic rays are real. Their effects are documented extensively. Superpowers aren't among them. The Fantastic Four exist because 1960s comics needed scientific-sounding origins in an era when radiation seemed magical. The premise felt plausible to contemporary audiences. It doesn't survive modern understanding. The films will hand-wave the physics because the alternative, accurate radiation effects, means cancer and death rather than stretching in flames. That's the bargain superhero cinema makes. Enjoy the spectacle. Don't expect the science to work. And if you want to understand what cosmic rays actually do and why NASA takes space radiation so seriously, that's real physics worth learning. Subscribe for more explorations of where comic book science meets physical reality.